So I mentioned earlier we have a special guest. We like to consider him special. We love the guy. I'll give you a little history. The gentleman that I'm about to introduce developed this technology that you see right here. This is what we call the Dappolito array. The gentleman I'm about to introduce, Joe Dappolito, actually also wrote the book. I think it's the only book, Joe, is that correct, on speaker testing?
Therefore, it's definitive.
It's the definitive speaker testing book. But you have the honor tonight of not me talking about these speakers, but the actual gentleman who developed them, designed them, and built them without compromise, Joe Dappolito.
Thank you. I'd like to spend a few minutes sort of tracing the history of the design of the Illusion A7. A few years back, Snell Acoustics was acquired by D&M Holdings. And shortly after they acquired us, they said, you have to make a statement loudspeaker. That is, you have to develop a flagship. Not only to show off our design talents, but also as a marketing tool. They asked us to make the best loudspeaker we knew how to make. And that's what you see here, the Illusion A7. So when we were given this task, first say, well, what is the best loudspeaker we can make? What properties should it have? Well, everybody knows about frequency response. It should cover the entire range of human hearing. It should play loud. It should have low distortion. But all good speakers have this. How do you make a great loudspeaker? And I think from my experience, there are two things that make a great loudspeaker, and you don't hear much about them. For years, there's been a mantra in the design industry of loudspeakers. First and above all, get the mid-range right. That's where all the action is in music. The bass gives you a foundation, the treble gives you the air, that sense of air, but everything that's happening is happening in the mid-range, and you have to get the mid-range right. And we'll talk about what that means a little later. But there's one more thing that a really good loudspeaker has to have, and that's dynamic impact. The speaker literally has to keep up with the music. Perhaps a way of illustrating this is, you say, well, the music isn't quite loud enough, I'll turn it up a little more, and I'll turn it up a little more. And as you turn the volume up on ordinary loudspeakers, say, strange things start happening. The sound field collapses. It starts to sound muddy. It starts to sound dull. You've lost the imaging. You've run out of dynamic range in the loudspeaker. If a musical passage comes along with suddenly a great increase in volume, and say, technically, over a period of milliseconds, there is a large orchestral climax, and the volume has to go up by 15 dB. Does the loudspeaker go up by 15 dB? If it doesn't, the dynamic impact is lost. And many poorer loudspeakers, especially if they're playing at a good volume level to begin with, can't make that extra 15 dB. And that's when everything sounds dull and collapses inward, and the image disappears. So, first and foremost, in developing these speakers, I was aiming at dynamic impact. A reference point for this is the THX specification. Now, these speakers have been designed with the ultimate in two-channel stereo reproduction in mind. But we also designed them to the THX specification, and the THX spec specifies frequency response, maximum sound pressure levels, distortions, so on and so forth. We've designed to that spec, but we've also added the dynamic impact that isn't in the THX spec, but leads to realism. Okay, so how do we do that? Well, to get a perfect mid-range and to get the dynamic impact, first and foremost, you need the very best drivers that technology can give you today. That is the best woofers, the best mid-range, the best tweeters. You'll notice also this is a three-way system. So, and I'll talk a little bit about that also in a moment. But we've been working for a number of years with a very highly respected European driver manufacturer called Seos. They're based out of Norway. And unfortunately, in this day and age, if you want really good drivers for high-end stereo, you have to go to Europe. The American manufacturers, and there are many good ones, have decided that all the sound's in the pro market. You can't get good high-end drivers out of the American market for the most part. You have to go to Europe. Now, we've been working with SEAS for a number of years, and we told them about this project. They got very excited too, and agreed to work very closely with us, developing drivers to our specifications. For instance, with regard to the mid-range, we took a standard 115 centimeter driver that they had, which was designed for broad frequency range, and we asked them to modify it so that it would become the ultimate in mid-range reproduction. And we did that by basically reducing the mass of the moving elements and increasing the motor strength so that this driver could now react very rapidly to transients within its operating range, its frequency range. And that was very critical to getting the kind of mid-range sound we wanted. So these are custom for us. Similarly with the woofers, these are 10-inch woofers with very long throw. To get the sound pressure levels we needed, that's another point, we needed 2 woofers, and we needed 2 mid-range. And of course, the 2 mid-range had to be in the Dapolito configuration. I'll talk about that soon in a minute too. With regard to the woofers, we had those redesigned to present a better load to amplifiers, so that the loudspeaker and the amplifier would work well together. Fortunately, at the time we were developing this, SEAS had come up with their own statement tweeter. They built the best tweeter they thought they could make, and they called it the Crescendo. And so the Crescendo is in there, and we didn't make any changes to that. So once we had the driver selected, the next question was, how do we put it all together? And to do that, we started out by building a number of engineering prototypes, and the engineering prototypes allowed us to come up with preliminary design equations and preliminary design models, which we could use to further tune the design. And by about the 3rd iteration on the prototypes, we had enough information to go to the cabinet shop and to go to our designers and say, make us a loudspeaker that is visually stunning, that doesn't look like anybody else's loudspeaker. Here's the volume requirements you need. We would like smooth baffle configuration so there are no response anomalies due to diffraction. And what can you do for us? And our industrial designer, a fellow named Gerd Schmiede, German, from an Eggplant Design School, came up with a truly unique cabinet. It doesn't look like anybody else's. He designed an enclosure with an elliptical cross-section of constant area. And the ellipse major and minor axes are roughly the same at the bottom. It's almost circular, and it's wide enough to accept the woofers. Then the ellipse rotates, and the major axis becomes larger, the minor axis becomes smaller. The cabinet gets more slender as you go up, and that provides us with an excellent baffle for launching the mid-range and tweeter. There's also very smooth contour. There are no sharp edges to cause response anomalies. Very, very clever design. So, as you walk around this loudspeaker, the shape constantly changes. You walk in the room. This doesn't look like a B&W. It doesn't look like a Wilson Audio. It's not a square box with exotic veneers. It is a unique shape. And it does exactly what we want acoustically.
Can't be confused with a trash can. Some speakers look like they're trash cans.
Some speakers look like they're trash cans, some look like shipping cartons, but you put an exotic color wood veneer on it and suddenly it's very expensive, but not necessarily very good. I won't go into all the details here, but this was a bear to manufacture. Once our industrial designer had come up with a basic shape, the mechanical engineers developed detailed drawings, CAD drawings from it, and the CAD drawings were translated into machine code for a numerical, an NC machine, to actually carve out all the parts. It takes about 6 hours to generate the individual parts for this loudspeaker, which are then assembled, glued together. There's a sealing going on, finish sanding, and then an automotive finish is put on it. There's one other point here in the design. These bezels, these are cast aluminum, finished machined bezels, which hold all the drivers in rigid alignment with one another. It's the same with the woofers, and it's the same with the port exit on the back. So it's really a complex construction, and it's all built in our shop.